But like everything, computers have come through telescopes as well. So you have computer controlled, or what they call GoTo telescopes. And they come in both types. You get your equatorial and the fork mount, the Altaz. And you'll probably see both of these types out there tonight, particularly when your eyes are dapped, not when you go out first. So this is a GoTo, this is an equatorial. So you have your little motors, there's control electronics in here, there's the computer in the little hand control. You have to have an external 12-volt battery or a car. Another motor back here. So you have all these other little bits that you've got to have with your GoTo as well. The procedure, some of these you only do once. You have to enter basically where do I live, which is your latitude and your longitude, or you can get them, like mine has GPS, so it goes and finds it itself anyway, so you don't have to tell it. And then you select the menu, like you might say Sirius, and Sirius is probably, I don't know, about out over there somewhere, and it might point to there. And then you just manually move it around until Sirius is in the middle of the crosshairs, and you go, yep, another star. Might move to Alpha Centauri, which is sort of out over there somewhere. Then it'll be fairly close the second time. You move it till it points to the second star. You go enter. And then with a lot of them, that's all you do. You have to set up 2 points with 2 stars. The further apart they are, the better. And then the little computer, the little brain in the computer can then follow where all the stars go relative to those points for perhaps several hours or most of the night. And it knows where all the other stars are, and it can calculate how far to move to find those stars, because it knows where these 2 points are. And it's moving them with time in its little brain continuously. And all the other stars are certain distances, so many degrees here, there and everywhere. So it can find all these other things for you. And that alignment procedure, usually about 5 minutes. So 5 minutes to get my mount out, 5 minutes to set it up with the stars. So 10 minutes minimum. This is about, as I said, 60 seconds and you're ready to go. The advantages are that, of course, you only need to know a couple of bright stars, and then you can find everything else in the database. But you do have to know the difference between Alpha Centauri and Beta Centauri, because if you say Beta is Alpha, then everything will be this far out, and you'll wonder why the hell you can't find anything. So you do have to know those few stars that you have to know. Some of the newer ones, some of the Me's, you actually just plonk it down, you press go, and I haven't seen them working, but apparently they go around and they find a star, and they have a little CCD camera, and they center that star, and they can work out what star that is, and then they buzz off to another star, and they find it itself, and they work out what star that one is, and they do it all themselves. So you don't even have to know where anything is. One of the advantages, which I've done with mine a couple of times, if you set it up at night and leave it set up, particularly if it's not going to rain, you come out the next morning, you turn it on, and I've done that. It was in the middle of November. It was a stinking hot day, like 38 degrees. It was about 12 o'clock in the afternoon, so full sun. I said, Alpha Centauri. And around it went, out to there, points at blue sky. You look in the eyepiece, and there's Alpha Centauri. At 12 o'clock in the afternoon, in the summer, bright sunny day, there's Alpha Centauri. You know it is because it's a double, and you can see the 2 stars with a blue backdrop, not black, blue, sky blue. You can't do that with manual telescopes unless you've got a lot of patience, because there's nothing to navigate from. But the GoTo will take you to the brightest stars. I think that day I found down to about the 6th or 7th brightest star I could locate. Some of the other ones I couldn't because they were in the northern hemisphere. But I found 5 or 6 stars at lunchtime on a November day. In the middle of the day, stinking hot, 30-odd degrees, and you could look at stars. Something people don't think of doing. I mean, you wouldn't actually do anything serious, because what are you going to do anyway? You can't take any photos because it's too bright. It's interesting that if they're properly set up, you can turn them on through the day. The disadvantage, of course, of a GoTo is it's a lot of mucking around. There's all this setup. Some of it you only have to do once, but some of it you have to do every time. So it's a lot more fiddling around. And a GoTo mount is about twice as much for the same telescope. You pay twice as much and you get the same telescope with the computer in. So instead of $1,000 for a fairly good computer or good telescope, $2,000 for the same telescope but with motors and a computer. And of course, when the battery goes flat, that's it, you want to go home. If you haven't got another battery, you can't use them. They have no manual adjustment. And you can't push them and move them or anything because it's just not how they're designed. So if you don't have a battery, it doesn't work. Now the big bugbear of a lot of people is the finder. And the first thing a lot of beginners have a problem with is they can't find anything. And the reason is because this little telescope is not aligned with this big telescope. You imagine if this one is pointing up there and that telescope's pointing there, and you find you're targeting your little finder, it's not going to be in that telescope. The reason you have a finder is it has a very wide view. So when you want to find something, it only has to be in generally the right direction, and you can move it around in the finder until it's in the middle. And if these are aligned, when it's in the middle here, it'll be in the middle of this one. That's why they call it a finder, because it helps you to find these things. Because the field of view of some of these bigger telescopes is like looking through a straw. I don't know about you, but if you just had a straw and someone said to you to find a particular star, I doubt you could. So you need this wide-angle view. Now they usually have adjustment screws like this one. It has a couple of screws, and that moves that telescope up and down and to the left and to the right, and you use that to centre it. So to align the finder scope, imagine we're looking at our field here. With the finder you might see all these stars inside this circle. The actual telescope is a much smaller view. If they're aligned perfectly, then what's in the middle of this large view will be in the middle of the eyepiece, and you'll be able to see that same object. Like if you're trying to get Jupiter, if Jupiter is in the middle of this big field of view, say if that was Jupiter, you would just have to move the telescope over until this was in the middle of the big finder view, and when you're looking through the telescope, it would be right in the middle. Not a problem. If they're poorly aligned, you imagine you're looking through your finder and you want to look at these couple of little stars down here, and you look in the telescope and it's full of all these bright ones and you don't know where the hell they came from because they're not in here, because they're looking at two different things. So they have to be aligned. It's really important. This is best done in the day.
How do you use the finder? Which eyepiece? Has that got its own eyepiece?
It has its own eyepiece.
Oh, is that what you
Generally they're not adjustable. So this is just like a fixed telescope. They usually
you walk through.
You just look through here.
Through there.
Yeah, just look through there.
Okay.
These generally don't even have focus or anything. They usually have a little crosshair, so when you look through you'll see a little black crosshair, so that you know when things are in the middle. But they're usually fixed. This is a fairly small one. Most of the bigger telescopes are usually about 50mm across or something like that. You have a fairly wide view. But they have no adjustments for focus or anything. You can't change the lens or anything like that. So the best thing is to do it through the day. You find something a fair distance away. The daytime's good because you can see so many things, and you can find, you know, the top of a power pole or the corner of a building or something like that that's identifiable, and you'll know when you find it. At least a kilometre away. The further the better. Much more than a kilometre, it doesn't matter all that much. What you have to do is you centre the thing in the telescope first. The way you align the telescope, or the finder, is by starting with the telescope, and you actually move the finder, not the telescope. So you move the telescope over until you find something identifiable like this little corner here of the building. And then you look through the finder and you can see the thing that's in the middle of the telescope is over here, and this is the crosshair in the finder, so obviously they're not aligned. So you would need to move this finder, you would adjust these across until that crosshair lines up with this part of the building that is in the middle of the telescope. the thing you have to remember, if you've got a computer controlled one, turn the motor off, because otherwise it'll keep moving. I've done that a couple of times, you line it all up, and you go, why is this not working? It's because the telescope is moving all the time. The building's not moving, so when you go back, the building's in a different spot. So you have to remember to turn the motor off if it's got a motor. Right, so you adjust the finder until, when you look through the finder, there's that part of the building. When you look through the actual telescope, you're looking at what's in this other circle, and you see the middle of one is actually in the middle of the other, so you know when you look in the finder, the middle of the finder is in the middle of the telescope. So it's all lined up. Then you'll be able to find something. Then of course you need eyepieces. Right? We know how many different types of telescopes there were. There's probably 100 times more eyepieces. There's so many to choose from, all different types. So all the telescopes have a focal length. That's basically how long it takes for the light to come to a focus. So the focal length of this, because it comes from here, goes up and comes out here, the focal length is probably about that sort of length somewhere. It's usually written on the tube somewhere. Focal length of this one is pretty much the length of the whole telescope. They also have an F ratio, which is basically how quickly it brings the light to focus. So you've got an F10, the light comes to focus more gradually. F5, it comes to focus faster. If you had an F3, the light would come to focus very fast, which would mean the telescope would be much, much shorter. And it has other problems as well, if you do that. So the magnification, basically you take the focal length of the telescope, divide that by the focal length of the eyepiece you've got. So if you've got a telescope with a 500mm focal length and you put a 10mm eyepiece in it, you'll get a magnification of 50 times. Easy to work out. The focal length will be written on the telescope somewhere. You can see these telescope eyepieces are all very different, but they're all the same focal length. So if you put any of these into this telescope, you'll get the same magnification. The quality may be different, but it'll be the same magnification. Everything will appear to be the same size. If you put it in a bigger telescope, you get more magnification because the focal length is usually longer. So the magnification just goes up. The eyepieces also come in two main sizes, 1.25". Well, this does actually have an eyepiece. Right, that's 1.25", so it's 1.25" diameter here. Or 2 inches, they're much, much bigger. 2 inches in diameter. Some eyepieces actually have 2 barrels. So they either fit in 1.25" or a 2 inch. Or you can get adapters so you can put your 1.25" into a 2 inch focuser. This one will only take 1.25". A 2 inch would be much bigger. That's also looks like 1.25" too. So 2 inches is about that size. So they come in 2 different sizes.